Imagine you spend your entire life memorizing facts from an encyclopedia. Like, you learn with absolute certainty that a specific person, let's say Tom Cruise, was born in Syracuse, New York.
Right, a very specific data point.
Exactly. You've read it 1,000 times, you can recite it flawlessly, but then somebody walks up to you and asks a slightly different question. They say, who was born in Syracuse? And your brain just, well, it completely blanks out.
I just have no idea.
Yeah, it literally cannot compute the answer. You just stare at them, completely empty. Now, for a human, that's not just a memory glitch, right? That sounds like severe cognitive trauma.
It sounds like something is fundamentally broken in the brain, yeah.
Right. But what if I told you that this exact catastrophic failure is happening like millions of times a day inside the most advanced artificial intelligence systems on the planet?
Wow. Millions of times a day.
Yeah, and it's not a bug in their data. It is a fundamental structural blindness. And right now, it is the fatal flaw hiding inside every major AI on Earth.
I mean, that fundamentally forces us to reconsider what we even mean when we use the word intelligence, because we have this very comforting narrative in the tech world right now, don't we?
Oh, absolutely. The narrative of scale.
Right. We assume progress is just a matter of scale. Like, you build a taller ladder, you add more data, you throw a few billion more parameters at the problem, and eventually the machine just, climbs its way to true physical understanding.
But when you actually step back and look at the physics of cognition, the mathematics of how reality actually flows from one second to the next, you realize that the ladder we're currently climbing is leaning against the completely wrong wall.
It really is. That is a heavy phrase.
It really is. What does that actually mean for a large language model? Like, what is an LLM fundamentally trying to do when I type a prompt into it?
Well, if we strip away the conversational interface, the absolute core operational objective of a modern autoregressive large language model, which is almost exclusively built on what we call the transformer architecture, is sequence-to-sequence mapping.
Okay, sequence to sequence.
Yeah, it is entirely optimized for one single task, which is next token prediction. It looks at a preceding window of context, and it calculates the statistical probability of the next piece of the sequence.
So it's basically playing the world's most complex game of autocomplete.
Right, exactly.
It's just guessing the next word or the next pixel or, I don't know,
Right.
the next line of Python code.
Precisely. But here's the critical flaw, right? This is the place where the illusion really begins. In that computational paradigm, time does not actually exist.
What do you mean it doesn't exist?
I mean, not as a physical, metabolic, or dynamic variable. Time, for an LLM, is conceptualized merely as a static index in a sequential array. The transformer architecture doesn't read a sentence word by word from left to right like a human does.
It doesn't.
No, it processes all of the tokens in its context window simultaneously. In parallel, it sees the entire block of text all at once.
Wait, I'm trying to picture this. If it sees the entire paragraph at the exact same time, how does it know the order of the words?
That's the million-dollar question.
Like, how does it know the difference between the dog chased the cat and the cat chased the dog? If it's processing them simultaneously, aren't those just the exact same pile of words to the computer?
Left to its own devices, yes. They would just be an unordered pile of words. The model would have absolutely no concept of sequence. To enforce the illusion of sequential time and to prevent the model from cheating by looking at future context during its training phase, engineers have to rely on explicit external mechanisms.
So they have to bolt on a fake clock.
They bolt on a fake clock. The two primary tools they use for this are positional embeddings and causal masking.
Okay, let's break those down. Let's start with the first one. What is a positional embedding?
A positional embedding essentially involves taking a token, say the word dog, and mathematically attaching a vector to it that acts as a spatial tag.
A spatial tag.
Right. You are basically taking a sticky note, writing position number 5 on it, and slapping it onto the word before you feed it into the massive parallel processor.
So it's spatial. It's not a temporal tag at all. It's telling the computer, like, this word sits in chair number 5, not this word happened 5 seconds ago.
That's a perfect distinction. It is
Yeah.
purely spatialization.
We need to find the exact mathematical origin of AI's temporal blindness. Where's the fundamental flaw actually hiding?
Well, we have arrived at the absolute mathematical bottleneck. To find the source of the temporal blindness, we have to look directly inside the engine of the transformer. We have to look at the self-attention mechanism and specifically at its foundational mathematical operation.
Which is what?
The real value dot product.
This is where we peer under the hood. So For those of us who haven't taken linear algebra in a decade, how does self-attention actually calculate relationships between words?
The self-attention operation is essentially a massive matching game. It computes the interaction between a sequence of what it calls queries, keys, and values.
Okay, queries, keys, and values.
Yes. It is determining how much mathematical focus or attention each single element in a sequence should place on every other element. To calculate that interaction score, it relies on the dot product multiplying a query vector by a key vector. Now, without getting bogged down in writing out equations, the critical defining characteristic of this real valued dot product is its absolute commutativity.
Commutativity. Okay, let's unpack that word carefully because everything hinges on it. What does that mean?
Commutativity simply means that order does not matter to the math.
Order doesn't matter.
Right. In a commutative operation, A times B equals exactly the same thing as B times A. The mathematical interaction score between a past state and a future state evaluates to the exact same scalar number as the interaction between that future state and the past state.
Oh, wow.
Because the operation is completely order symmetric, the engine evaluates the interaction identically, regardless of the temporal sequence in which they are processed.
Let me try to build a conceptual analogy here because I really want to visualize why this is so catastrophic for understanding reality.
Go for it.
Imagine you are an accountant looking at a financial bookkeeping ledger. You have two transactions. In one transaction, you deposit $1,000 into a bank account. In the other, you withdraw $1,000.
Okay, very different events in the real world.
Exactly. Now, imagine a bizarre mathematical engine processing this ledger, where the operation for depositing and the operation for withdrawing use the exact same mathematical function, yielding the exact same output score.
The system would see them as identical, indistinguishable events. It would yield the same interaction value.
Right. The core mathematical engine calculating the ledger is structurally blind to the flow of the money. It has absolutely no idea if the money went into the account or came out of the account. The only way you, as an external observer, know what the direction of the money was is if someone artificially scribbled the words past and future in the margins next to the numbers.
And those scribbles in the margins are exactly the positional encodings we discussed earlier.
Right. The engine itself, the dot product, doesn't know. It just sees the interaction. Hypercomplex numbers.
Specifically, we need to introduce the four-dimensional quaternions into the bedrock of AI architecture.
Quaternions. Okay, hypercomplex math. Let's unspool this incredibly carefully. How does adding more mathematical dimensions fix the timeline?
It all comes down to the multiplication rules of quaternions. Unlike real numbers or standard complex numbers, the multiplication of quaternion units is strictly non-commutative and anti-symmetric.
Okay, meaning?
Reversing the order of multiplication does not give you the same result. It strictly reverses the sign of the product.
Let me make sure I have that exactly right. Reversing the order fundamentally flips the sign.
Yes. When two quaternions are multiplied together, the operation is known as the Hamilton product. And unlike the real valued dot product that powers the transformer, the Hamilton product entangles the four components of the vectors in a highly structured manner that is acutely, permanently sensitive to order.
So it knows which came first.
Exactly. The mathematical transition from state A to state B yields a totally different mathematical object than the transition from state B to state A.
I want to visualize this because hypercomplex non-commutative division algebra sounds incredibly abstract and intimidating.
No.
But it actually describes the physical world we live in much better than standard numbers do.
It's much closer to reality, yes.
Let's use a 3D spatial rotation analogy.
Hmm?
If you were listening to this right now, I want you to imagine picking up a physical book. Hold it out directly in front of you. Now rotate it 90 degrees forward so the top of the book tilts away from you. Then rotate it 90 degrees clockwise. Note its position.
Okay, it is facing a very specific locked orientation in three-dimensional space.
Right. Now let's start over. Hold the book normally in front of you. This time, we're going to change the sequence. Rotate it 90 degrees clockwise first. Then rotate it 90 degrees forward, tilting away from you. Look at the book. It is facing a completely different direction than the first time.
The final state is entirely different.
The exact same two movements, executed in a different sequence, change the final physical state of the object.
The physical universe cares deeply about sequence.
The physical universe is non-commutative. And the quaternion algebra, which was literally discovered by William Rowan Hamilton in 1843 when he was trying to figure out how to multiply points in 3D space, natively captures this exact sequential reality.
It does.
It doesn't need artificial causal masks or engineers scribbling past and future in the margins.
Exactly. In this algebraic structure, sequence natively dictates parity. The Hamilton product inherently encodes an arrow of time into the operation itself. The algebra enforces the sequence. By shifting to these non-commutative hypercomplex architectures, artificial intelligence can transition structurally from being a massive, flat, associative text engine into a physics-aware, dynamic trajectory calculator. Think of the unbroken mass of an object or an absolute temperature reading in a room, or an idealized non-directional continuum of time.
But they lack physical sequence. You cannot mathematically model dynamic, spatial reality, or a car crashing, or a human hiking up a mountain with just a single thermometer reading.
Exactly.
The reals are perfectly safe, but they are frozen. So we step up to step 2, two-dimensional space. The complex numbers.
In complex numbers, we double the dimension. We introduce the imaginary unit, I. Suddenly, we gain an incredible new mathematical power. The ability to describe two-dimensional planar rotations, electromagnetic wave functions, and quantum probability amplitudes.
But we lose something.
Right. In mathematics, there is always a trade-off. By stepping up the ladder, we lose a property. In 2D, we lose ordering.
Wait, what does losing ordering mean?
It means we can no longer just put them on a single, simple number line. If I give you two complex numbers, you can't simply say one is definitively greater than the other in a linear sense. The concept of greater than loses its absolute meaning when you are dealing with a plane rather than a line.
Oh, that makes sense.
However, they are still commutative. Sequence still doesn't matter in their multiplication. A times B still equals B times A, so we still don't have an arrow of time. We must step up again.
Okay, step 3, four-dimensional space. The quaternions.
This is the absolute sweet spot of the universe. We double the complex numbers, introducing 3 imaginary units, I, J, and K. And in doing so, we cross a monumental threshold. We finally lose commutativity.
We finally lose it.
Yes. The temporal order of mathematical operations now irrevocably alters the outcome. A times B no longer equals B times A.
This is the mathematical birth of the arrow of time. This is the book rotating in our hands.
Yes. Because commutativity is lost, the algebra natively, structurally understands strict sequence and continuous physical transformations. It understands that you cannot unburn the wood. This is exactly why quaternions are fundamentally necessary for world models attempting to map temporal states.
It's built into the math.
But crucially, and this is why 4D is the sweet spot, while we lost commutativity, we kept associativity.
Okay, we kept associativity. What does that mean practically for a physical universe?
Associativity is the rule that says A times the group of, B times C is equal to the group of A times B times C. It guarantees that consecutive sequences of transformations evaluate deterministically, regardless of how they are arbitrarily grouped by an observer.
Yep.
If event A causes event B and event B causes event C, the overarching physical laws governing that sequence remain completely stable. The universe doesn't mathematically glitch depending on how a scientist brackets the equations on a chalkboard.
4D is the sweet spot. If 4D is the perfect balance of sequence and stability, what happens if we keep climbing the ladder? Let's push the math further. Step 4, 8-dimensional space. The octonions.
When we double quaternions to create 8D octonions, we pay a massive mathematical price. We lose associativity.
Whoa. Wait, we lose bracketing.
Yes, the very fabric of consecutive transformations becomes ambiguous. If you have 3 events interacting in an 8-dimensional octonion space, the way they group together mathematically fundamentally changes the reality of the outcome.
So A times B times C is different.
It is no longer guaranteed to equal A times B times C. Without strict, externally imposed bracketing to hold the math together, the universe becomes inherently unstable. Events lose their deterministic chain of cause and effect.
That is terrifying. But let's go one step further. Let's look over the edge of the cliff. Step 5, 16-dimensional space. The Sedenians.
In 16D, the mathematical structure of immutability completely collapses. We lose the property of being a division algebra. We gain what are called zero divisors.
Zero divisors. I need an explanation for that because that sounds, well, apocalyptic.
It is apocalyptic for a physical universe. In normal math, the only way to multiply 2 numbers and get 0 is if one of the numbers is 0. But a zero divisor means you can take 2 entirely non-zero entities, multiply them together, and the result is absolute 0.
Yes, 0.
Imagine 2 complex mathematical matrices full of energy states and physical data. They collide, they interact, and the output matrix is just entirely empty, zeros across the board.
So if a universe ran on 16-dimensional Sedinian math, mass, energy, and physical information could spontaneously interact and literally vanish into the void of the mathematics itself.
Exactly. It would spontaneously destroy physical conservation laws entirely. Reality would just delete itself upon interaction.
That is genuinely mind-bending, and when you lay it out like that, it becomes so clear. The 4D quaternion algebra isn't just a random choice. It is the absolute maximal boundary of associative immutability.
It's the limit.
It is the most complex math mathematically possible that allows for movement, rotation, and an arrow of time without destroying the deterministic laws of physics.
Yeah.
If artificial intelligence is going to truly simulate our physical universe, it has no choice. It has to adopt the exact mathematical structure that governs our universe.
Synthesizing this entire journey from the reversal curse to the Cayley-Dixon ladder, the conclusion is absolutely unavoidable. Artificial intelligence must evolve. It cannot remain a massive, flat, associative text retrieval system constrained by the commutative dot products of the transformer architecture.
Just can't. Just can't.
If we want true artificial agency, if we want advanced robotics, deep spatial planning, and machines that interact with the physical world safely and intelligently, they must fundamentally transition into coherent, physically grounded world models using non-commutative hypercomplex algebra. They must possess a metabolic, structural, mathematical sense of time.
And why should you, listening to this, care about the intricacies of four-dimensional hypercomplex algebra? Because we are rapidly moving toward a future where AI systems won't just be generating paragraphs of text on a screen.
Right. They will be physical agents.
They will be operating humanoid robots in your home. They will be driving cars autonomously on your streets, and they will be calculating physical trajectories in the real world right alongside you. A machine that is mathematically blind to the irreversible flow of time, a machine that just views the world as a flat, commutative map, is not a machine that truly understands the physical consequences of its actions.
It's a danger, honestly.
It is. But before we sign off today, I want to leave you with a final provocative thought, inspired by our climb up the Cayley-Dixon ladder. If our physical reality and the artificial intelligence we need to build to survive in it strictly requires a four-dimensional algebra to preserve cause and effect, what kind of theoretical intelligence or what kind of bizarre alternate universe might natively operate in an eight-dimensional Octonian space?
That is a fascinating question.
A space where sequences of time are inherently ambiguous and the very grouping of events alters the physical fabric of reality? What kind of mind could navigate that? It's something to mull over.
It fundamentally reframes what we consider to be possible physics and what the ultimate limits of cognition might actually be.
Thank you for joining us on this incredibly layered exploration. We covered a massive amount of conceptual ground today, from the mechanics of LLMs to the structural bounds of reality. If you found this deep dive valuable, please subscribe to the show on Spotify, Apple Podcasts, YouTube Music, and value for value platforms like Fountain.fm.
We'd love to hear from you.
Yes, and please, we really mean it. Submit your own research papers, your philosophical frameworks, your technical references, your obscure readings, and your favorite rabbit holes for future deep dives. Meaningful structural ideas emerge through a collaborative synthesis between human curiosity, AI acceleration, and our recursive refinement.
Keep questioning the underlying structures of the technology you use every day.
Keep searching. Keep refining your models of reality. We'll see you on the next deep dive. I'm Satoshi.
And I'm Satoshi.